Hello, everyone. Welcome to this week's binary episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have a TOCTOU and Intel SMM, some Kerberos bugs, an XNU race used after free, and some Shannon Baseband bugs. Before that, though, as always, Z will get into this week's Spot the Vuln challenge.
Or at least I will if I can change the tabs here. Yes, this week's Spot the Vuln, called it the right context. Should be or if you're reading the code, should be clear that there's something going on here with the cserve token. There isn't a lot of attack service with this. So you have two functions: is valid, takes in a token and a context value, returns a boolean, an update user, which generates or has like a static string for the context, gets the token out of the request form, and passes it into the is valid function. If that returns poorly, it just says invalid token. So kind of what you'd expect out of a validation thing here. What is a little bit unique is it is doing kind of a contextual validation, although we don't really see a lot of it. A lot of the context that could be generated, but it is validating like that this token was created and was created for like the context you're trying to use it for. So in theory, it could be a little bit more secure, but the problem here is, well, in the is valid section, it'll take the token context and looks those up. See, is this token with this context in the table of tokens, and has it expired? So that makes sense, but what it doesn't do is it doesn't validate that the owner ID actually matches the user anywhere. Doesn't actually even pull out the user anywhere to check if they're authenticated or anything, at least in this code. But since this doesn't return the owner ID, like you'd expect is valid to also check the owner ID. It doesn't do that. And so an attacker could basically take their own cserve token and just use that to attack any other user. Definitely something that would be easier to find, I think, if you were doing dynamic testing rather than looking at the code. In the code, you kind of have to think through it a little bit more, whereas dynamically, you would probably just test this case already, just copying another thing, because it is not necessarily a common issue, but when I've seen cserve fail, it is one of the ways that I've commonly seen it fail. Interesting, IABR in chat mentions GPT-4 managed to solve this, so if you didn't, it's smarter than you. I find that interesting because I actually tried to get GPT-4 to solve this, and 3.5, and it didn't, actually. At best, it called out SQL injection, telling me that I was passing the token right into the query when I'm very clearly not. But yeah, it didn't come up with the core vulnerability here either.
Yeah, ChatGPT seems to really like assuming that SQL injection is present when it isn't. It just sees like a SQL query and it's like, oh, there must be an injection there. Because it did that on a few of the things I tested before too.
Yeah, it did give some other things like, oh, maybe there's a timing attack in the database or something that called out when I ran it. IABRS, did you use ChatGPT or the GPT-4 playground? I used ChatGPT Plus, which has the GPT-4 model, but yeah, I didn't use the playground itself with access to GPT-4. I don't have API access. I
Feel
just
free
have
to share
access
those screenshots though. Like I would be interested to see.
Actually, yeah, I can pull them up here pretty quickly.
Yeah. Oh, I mean for I8BR, where he mentioned he was gonna
where it
the
solved
screenshots
them?
of Playground. Yeah.
Well, still, since we're talking about it, I can actually bring up the solution it gave, or it gave to me.
That's a lot of issues.
Yeah, well, I asked it in the first screenshot here. I asked it specifically for vulnerabilities or code smells, expecting it to give a little bit more, and so this was everything that it kind of listed to me. And while it does talk a little bit about the is valid thing, it doesn't actually talk about the issue that matters. It makes a lot of assumptions about all the things that could go wrong, like you're not using a proper RNG. It calls out the missing auth check and update user, which, it could be, that would, in theory, I would expect that to be in the just commented out code, but either way, these are the things that GPT-4 specifically gave me via ChatGPT Plus.
Yeah, and we haven't really talked about GPT-4 very much, but Z has been using it a bit with some of the topics that we've been covering, mainly on yesterday's episode, and it seems to do a pretty decent job, actually. I think it is a decent bit better than 3.5 was, at least when it comes to like the technical topics. It's unfortunate though that the GPT-4, or at least the ChatGPT API, is so rate limited, and sounds like it's going to be worse for that. So it's not going to be as fun to play around with or try things with, because it's going to be like almost unusable. But
Yeah, they currently have a cap of 25 messages every 3 hours, but also a little warning there saying to expect significantly lower caps as we adjust for demand. Yeah, and just to be clear, I've mostly been using it to try and summarize some of the blog posts. Like I would, give it a little prompt and then give it the blog posts that we're covering and have it kind of generate some summary that um kind of hoping, like, my hope was that it would help me kind of understand the vulnerabilities a little bit quicker. So if I go into it kind of knowing where the write-up's going to go, I find it a lot easier to understand the write-up if I know what their end game is. And sometimes the write-ups just feel a
take a
little
while to get
bit,
there.
yeah, they take a while to get there. So like the one post we covered, I want to say like 3 or 4 episodes ago, where they kept
Kept going through
like,
things that didn't work.
yeah,
Yeah.
and it would kind of cut down on some of that reading where I know, like, okay, this is where they're going with it. So when they're not there, I can perhaps glance over more of the content, because we do end up reading a lot of posts here. IABR mentioned that he just posted GPT-4 solving this.
All right.
I'm just going
Do
to
you
pull
have
up.
that? Or
Yeah,
okay.
I'm just pulling up the image here. Okay, so I did call out the
Interesting.
SQL injection thing, just saying, although the code seems to be using it, make sure that all queries do that. But fair, yeah, it does call out the core issue there, the incomplete CSRF protection. Checks if it's valid, doesn't check if it's the right user.
Yeah. I mean, like I said, I was pretty impressed with the summaries it was able to come up with for a lot of the topics. They were pretty accurate all around. So yeah, it might be useful for looking at some of these write ups. Of course, you do still have to be careful that it's not misleading you. But
Yeah,
yeah,
it does
it
tend to
seems to be a pretty good
hallucinate.
step up on the technological side.
I will call out actually that OpenAI put out like this safety sheet. I forget exactly what it was called now. They put out like a little white paper where they actually tested like GPT-4 and the impact it could have in a variety of areas. One of those areas was cybersecurity. And they call out kind of that same issue where it's like in small code bases, if you give it something sufficiently small, it can find vulnerabilities, but it also has this tendency to start kind of hallucinating about what's in there and stuff, which is kind of the issue that I was calling out, where it'll make things up. You kind of need to have the background and understanding to work out when ChatGPT is right or wrong already. It Otherwise, you can't just blindly trust it, I guess.
It's not a learning tool, is how I'd put it.
Yeah.
Despite people, I've been seeing people recommending it as such, and it's not a good recommendation. You kind of have to be able to triage it, almost be able to triage what it's giving you. So
Although on that note, I will call out, and I've only played around with this very briefly, but SecGPT. I know I wasn't planning to go into this on this episode, so I'll need a quick moment to try and find the link again. But it's basically a GP that has had extra training done specifically on vulnerability write-ups. And I passed it in a few just test cases, like something ChatGPT fails with, or I haven't tried with GPT-4 yet, is like, what's the difference between cop and ROP? I've asked it that. It just goes off and like some other very random things, whereas this was actually able to answer it. Um,
that's cool.
Fortunately, I'm not. I saw the link just on Discord, and yeah, I'm not seeing it right now. So I'll try and add that into the show notes if I remember. But yeah, it was just like a special AI thing that was trained. Actually, I do remember this. It was alterai.me slash. Yeah, there we go. Found the link now that I randomly remembered it. There was kind of a tweet. I guess I need to log in, so I can't do that now anyhow. But yeah, I'll make sure the link is just in the show notes at least for you guys. But I don't know, it was interesting. The cost seems a bit high. I don't know if it's really going to be worth it. I want to play around with it a bit more, but applying it specifically to security, you can ask single questions. Seemed kind of cool.
Yeah. All right, so getting into some topics. Up first, we have a TOCTOU in Intel's SMM, or System Management Mode. And Z, I'll let you get into this one.
Yeah, and this is. I felt it was kind of interesting because it feels a little bit backwards from what I would have expected the code to be doing if it's going to be vulnerable here. But what you have, or at least it does one part of this backward. Key thing that's going on is it's taking in a buffer, and it has this nice function SMM is buffer outside SMM valid. So it's basically checking the buffer that gets passed in, this COM or communication buffer. Key thing is it's trying to look, is this buffer, the information given in it, are they trying to point this in a way that's going to overlap the SMM's memory, right? So the SMRAM. Obviously, you don't want user input or even the output to be read or written into the SMRAM, into SMM's own memory space. So they have this nice check right at the start. So right off the start, you have the SPI handler. Right at the start of that, it is validating if this, I'm going to say user line pointer actually tries to point outside of it. It has another data buffer inside of. I should have made that more clear. This pointer then has a pointer inside of it and size and all of that, like all the metadata is contained inside there. So they make sure those pointers are valid and the size is valid and all of that. So that's good that they're doing that check right off, basically right at the start. So they do that. They allocate a local copy of it. Actually, I highlighted the wrong thing there, but they basically create like a local copy called the SMM SPI function header, copying it in so now they can read all of the values in there, and it's a local copy so the user can change it. Problem comes when you then enter SPI function flash read, so the handler for one of the commands. It goes and it grabs the pointer out of the external copy. So for whatever reason, they had the local copy that they just created of the user input, and they kept the pointer to the old original source buffer, which they refer to as the external copy of it. So basically it reads the data pointer out of that. So you might be thinking, and you might recognize kind of the issue here already, they performed the validation and then made a copy, and then they still use the kind of user editable version of this. So ultimately, between that validation and the copy and everything else, the values can be changed out from under it, allowing them to now point it into invalid range and corrupt the SMRAM, which can then lead to privilege escalation into the management engine.
Yeah, so basically, what it's doing here is it's reading from this. It's communicating with the spy flash. Funnily enough, these kinds of issues seem to be super prevalent across the board in both AMD, Intel, pretty much any vendor in the space that has this kind of firmware that's running at a higher level. Because I've seen this in the PSP with the AMD PSP research I've been doing too. They'll copy something from spy flash into a secure buffer, they'll validate it, and it's a stupid mistake.
You were cutting out there a little bit. Can you repeat the last though? Yeah.
Oh, yeah. I was just saying, I've seen these kinds of issues in the AMD PSP as well, where they'll copy some untrusted data from spy flash, they'll validate it, and then they'll just copy it again, even though they've already like copied it and validated it and everything. I'm not sure why, but for whatever reason, this kind of issue seems very prevalent in like that low level firmware. Um, that said, actually exploiting it is a bit tricky. Because like being able to read and write to the spy flash as an attacker is already a pretty high ask. You need a pretty high level of access, but not only that, to exploit like a TOCTOU type issue, um, like you're basically going to have to race the firmware. The only way I can really think of taking advantage of this is like a physical attack with like an FPGA or something. Um, I might be
Yeah,
wrong. Maybe there is some way to take advantage of it from software, but it is like it's a pretty hard attack to pull off. That said, something like the system management mode could be an intriguing target for various reasons. So because it does like sensitive actions like power management and all that kind of stuff. Like there is some cool stuff you can do if you can get there, but it's not something that's going to be easily exploited remotely or something.
no, and they
Um,
call that out right at the top. This enables a local or physical attacker with a DMA capable adversary to corrupt the
exactly.
SMRAM. So yeah, it is local. I feel like that's a valid attack surface when we are talking about the SMM. Um, like to have that sort of as I guess it would be more damaging if there were a way that so I'm trying to think about, could you hit this out of the kernel at all? And I mean, you really couldn't, not, or I don't think you could,
I
unless
don't
there's
think
something
so.
really weird going on, and like in some random device you have, like X random device gives you that sort of primitive, but I can't imagine that. That's not something that would normally be there. Um, so yeah, like that in that sort of case, that sort of attack would be more useful, but yeah, no, they call it out that this is a local DMA cable, though I didn't call that out, so good shout.
Yeah. Nonetheless, it is still pretty cool. And like I said, like these TOCTOU issues are everywhere when you start talking about like SMM and PSP and ME and all these things. Um, part of that is maybe just because they don't really think about it as much, kind of just flies under the radar. But yeah,
It's
it's totally
weird
fair to call
though,
out.
because like this, like effectively, it's a double fetch. Um,
Yeah.
in effect, that's what's going on here. It's that's what I found so weird about this one was the fact it did that copy and then just didn't use the copy. And it also validated before copying, so you had that race window there regardless. Like, even if it used that copy, because it's validated on the uncopied version, you still had a little race window where you could change it after it validated. Um, so yeah, I mean, we've known about these sorts of attacks for many, many years. It has exists in the kernel. Feels like, kernel is kind of dealing with that. You see that a lot less, mostly, it's got some attack surface left on Windows with drivers still being able to get there. Don't see it as often on Linux stuff. I guess IoT we still call it out sometimes, but I don't know. Feels like as now kernel is hardened, so we're seeing the same thing as you get a little bit deeper again.
Yeah, I don't remember if I said this on the podcast, but I know I've said it in Discord before. It feels like these secure elements or whatever are kind of in the same security space as kernels were like 10 or 15 years ago. It's like there's like a 10 or 15-year lag, and you're seeing a lot of the things that you used to see in kernel back then in functionality like the SMM or TPM or whatever. Um, and yeah, I think it's just because the code base is complex. You're doing complicated things, and uh, my speculation is just that they don't think that it's already been copied, so they're like, okay, let's go ahead and read it, not knowing it's already been read and validated. Just kind of getting lost in the functionality of other things. So yeah, it's still cool to see, but like I said, you would need some pretty high level access to be able to pull it off. So, which is something they call it in the report, as you mentioned. All right, so getting into our next report, we have GitHub Security Lab. They put out 3 vulnerabilities in MIT's Kerberos V5 library, all of which were out of bounds read issues and occurred when parsing and verifying SP-nego tokens, which is the simple and protected GSS API negotiation standard. Bit of a mouthful, not something I've really worked with, but yeah. The first vulnerability is like the most simple one, although they're all pretty simple. It's in the get mech set function, which will parse object identifiers or OIDs from the SP nego token that gets passed into accept security context. And these OIDs are basically in a sequence of distinguished encoding rules or DER encoded objects. So they'll have like a for loop to just iterate and parse all of those object IDs. And if they fail to add that OID into this returned mexset array for whatever reason, it'll just sort of silently fail and continue to iterate, which is a problem because the array size is now desynced from the set length. And since I is greater than the array length, since it was never added, when they go to access it on the next iteration for incrementing the set length, they can go out of bounds. Triggering this condition is somewhat easy as well. In order to trigger the failure case, you just need to have a zero-sized OID or multiple of them in their case in the set. So, just one of those cases where trying to handle the error case in a way that you can continue instead of just outright failing is kind of coming to bite them here. And I think that's an issue in some of the other vulnerabilities that were reported too.
Yeah, do kind of have that, although I will say it's the I value that's kind of desynced there. The set length, I don't think really gets desynced at all. Because set length is what they don't do when it fails, so and they haven't added anything, so it makes sense, but the next time they end up working with set length to increment it, that's where they end up using that invalid I value, which now is going to be 1 ahead of where it should be. Or X number ahead. If you do this multiple times, multiple zero length sequences, you'll end up incrementing I a bunch of times, so then that element will be far beyond what it actually is. So I believe it's the I that's kind of desynced from where it should be.
Yeah, it is. And it's kind of interesting too because, by controlling the amount of zero length OIDs you pass, you can kind of control how far out of bounds you go as an attacker too. So I thought that was a fun aspect of it.
Yeah, I was thinking about this one on exploitation. Unfortunately, I probably could have looked up the code to actually see a little bit more of this. For all of these cases, it seems like they really only got denial of service with them, and they would be challenging to actually weaponize. In this case, you've got this read, so assume you control I can go however far you want out of bounds, but all you're doing is whatever that value is going to set length, which seems to be some sort of buffer length. We don't actually have the code. I assume it's part of this ... that they've just snipped out for what exactly set length is doing, but it's being used as like set length less than length, so some sort of buffer check. So maybe really large value, increment it, get to wrap around and do something there. I don't know. I feel like whoever, like GitHub Security Lab, has probably thought through what could be done there and determined that really is just a DOS. But yeah, I was thinking about that a little bit. It is kind of an interesting little primitive to have. Unfortunately, it doesn't look super useful here.
Yeah. Getting into a few of the other issues, which, like I said, are sort of similar in root cause. The second bug was, again, when trying to verify an SP nego token. They would try to parse the context tag and get the number of bytes for the following DER sequence. Problem is, it's possible to have a zero-length sequence in ASN1, and they never verify that bytes is non-zero there. So when they increment the buff pointer to start parsing the sequence, they can go out of bounds on a zero-length sequence since there's no data there. The final issue is in the same code in gverify neg token init, and it has to do with the cur size and the tag length that's stored in bytes, as well as that same buffer pointer is the second issue. As I mentioned earlier, that buffer pointer is incremented to get past the size and get to the actual data, but they never account for that increment in the current size, and so it can go out of bounds when it tries to get the DER encoded length. And it could use an unsafe cur size because they just didn't account for that pointer increment. So that one's a bit of a more limited one. I think it's the most limited of the three vulnerabilities in terms of the primitives you would get. But still, that could be usable in some sense. Though again, they only call it the impact as denial of service. So fairly interesting set of issues. It is in code that's probably not looked at quite as much when it comes to like the token verification. They do look kind of tricky to deal with, expecting like different types of data and having to deal with what's there. So not super surprising, I guess, that there's issues there because it is kind of tricky to deal with. But yeah, they do seem pretty limited. I'm not sure how exploitable these would be. Um,
Yeah,
yeah, it
exploitation
kind of depends
is,
on the target and the context, I guess.
yeah, like exploitation seems pretty tricky, but the bugs themselves, they're interesting edge cases, especially like the zero length one, needing to account for that. They're nice bugs. I mean, even if we can't exploit them in a really nice way, I think the bugs are still really cool to see.
For sure. All right, so Project Zero put out some vulnerability reports this week as well. The first of which was disclosed in XNU by Ned Williamson. And Z, I know you found this one interesting, so I'll let you get into it.
Yeah, speaking of the interesting bugs, I think this is probably my favorite from the week. And it's this the super user check when using, or Play comes in here for this NFSD. I'm not super familiar on this area, so I'm not even sure what exactly is going on in this area, but it's a privileged area, or at least a couple privileged calls inside of it.
So I
They do
will
talk
quickly
about,
interject and just say,
go for it.
yeah, NFS in this context is for like the network file system stuff. So like the privileged off functionality here is for like adding sockets and adding daemons, I think, for the network file system. So it kind of makes sense why they want to keep that limited to super user. Um, you are getting pretty privileged functionality by being able to add your own sockets and stuff there.
Yeah, and the bug here comes down to when they do this super user check, what they do is they check, this UAP flag coming in, is that equal to either the NFS service AdSoc, or is it the NFS service like NFSSD? So I assume that's the add daemon thing you mentioned. They just check the equality there, but then in actually processing it, when they decide, hey, what handler are we going to use for any of these or whatever, you've got these if statements where they go and do the bitwise AND operation, checking if it sets the AdSoc bit or the NFSD bit. So you can basically skip the check, or the super user check, by providing a flag that has the bit set, so it goes to the right handler, but isn't exactly equal to that. Meaning that the super user check just never runs because it doesn't think you're trying to access anything privileged. Just a really fun bug and kind of a desync between how they're doing the comparison, those two places of code. I understand where the developer was thinking on this, because your normal use case, you are just passing in the one. But this difference does let them, or does let somebody just bypass that super user check completely by using some random bits that are not otherwise used, having those set so the equality check fails, but the bit check goes through. And this lets them access or hit a use after free vulnerability in AdSoc, where effectively what it comes down to is when the NFSD thing returns, it's going to try and, if there are no like workers left on, no threads working in there, it's going to try and clean up. So it's going to try and kill all the sockets that's created and all of that. It'll try and clean that up, and it'll grab a lock. And that lock is different from the lock that when you're using, I believe it's when you're using AdSoc, it will do this upcall, basically creating a work thread. And basically, you have these two different areas of code using two different locks to access the underlying socket that was created. So different locks, meaning when one is going to destroy it, the other can go ahead and enter that code anyhow, and that's not good. I don't know,
It
Spectre. I
highlights one
think,
of my favorite things to like keep a lookout for and recommend to people is like, just because you're using locking doesn't mean the locking is being done correctly. um Especially when you're getting into these complex areas where you have multiple layers of locking, it's very easy to like not grab one and for that to open up a race window. Locking is, it's very easy to get wrong, especially when it's complicated and goes beyond just one lock.
yeah, there can
um
be a lot going on here. Locking in general can be tricky to get wrong. As I said, when you get into those really specific locks, In a sense, a better pattern is to have like a massive lock around everything, but that also reduces performance significantly when you're like lock everybody out if you're doing any operation there. Not good for performance, so like kernels or anything don't do it, but if performance isn't your issue, like big locks or massive locks are generally going to be a lot easier to understand.
Yeah, and for those not too familiar with like the history of race conditions, that's kind of what opened up so many of them. Is like in the past, like let's say the 2000s, there weren't quite as many race conditions because a lot of locking was the giant locks. It was very coarse grained. But as performance started to become more important and you weren't getting as much free performance out of the hardware, one of the first places you go to optimize performance is to start moving toward more fine-grained locking, which is awesome for performance, but it does open up these kinds of issues more, which can create the races there. So yeah, I love this type of issue. Both types of issues are really cool, especially when you have the logic bug kind of opening up the way to exploit the UAF. They chain together very nicely, and they're in the same area, so it's cool there. Sorry, were you going to ask me something earlier, Z?
Oh, I was just going to say, I think you had a bit of a better handle on that bug if you want to jump in and add anything.
Oh, yeah. So it was a little bit confusing reading it if you're not familiar with like the XNU networking stack, which to be fair, I'm not really either. I had to look it up. He talks about like the upcall workers. Basically, what's going on there is like the add socket functionality will spin up a worker thread, and basically do the setup operation asynchronously to not block the user. So that's all that they mean by upcall worker. It's nothing too special, but it is terminology that you want to be familiar with to fully understand like what they're talking about. And yeah, to understand the issue better as well, there is a mermaid graph provided in the P0 report. So you just brought up an editor to render it. But it just comes down to like taking the different locks there. So yeah, effectively, there's no synchronization. You can just free the socket and the upcall data, which can be used by the upcall thread after it's been freed. Not really too much information on like the exploitability, but that's not too surprising. This is a Vuln report. He does go into like annotating the yeah, so I think the output of logs from his fuzzer, which uses something called concurrence, which is like his proprietary library for fuzzing for race condition type issues.
It is
Which
open source and not proprietary,
sorry, yeah, I should have used a better word there, but that's like
but
his
his
custom
own,
thing. It's
yeah.
um, which I do want to check out. Actually, I think it sounds pretty cool, but I haven't really gotten a chance to look at it yet. I think there is a presentation or something on it as well. You mentioned Z.
Yeah, he talked about it at Black Hat just this past
Cool.
one. So there's a presentation there. I've just brought up the source code, or yeah, the source code here. I thought this had the presentation on it too, but I guess not. Um, I'll try and get that link also added to the show notes.
Yeah. So not very much on the exploitation strategy, but I have to imagine with what I know about XNU and the primitives that you can get here, this probably could be taken to like a full exploit, especially when you chain in the logic bug. Which actually, on that point, I will say that kind of check that they do with the bitwise and for determining which operation to do is really weird. I can't really rationalize that, to be honest. Because
I mean,
I
if they're
get it. Like it's a
using,
flag check. I kind of see like, okay, if there's other flags, then maybe they want to mask those off to do the operation check. I don't know. It is kind of weird though.
I'm kind
I
of the
can't say I've seen a lot
opposite.
of code with that.
I actually felt like the equality check for the super user was the one that was off, and that using, because like I said, it is a flag, something you're going to expect to be a bit field. You have the bit field, like the bit values there also to use. I feel like the one that stood out to me was using the equality check rather than using the bit, but I mean,
Well,
it.
so I guess my problem is more on sticking the operation in the flag in the first place. I feel like that should be its own field. Because when you start trying to add like everything into bit fields and try to penny pinch on data this way, that's when these types of issues open up unnecessarily. I feel like.
Yeah, I
Um,
don't know what else is even in that flag, or if it is mostly. I assumed it was mostly just being used to indicate commands. Um,
yeah,
it's possible there is more in there. There definitely could be, in which case, this breaks down even more. But yeah, I mean, fair shout. I would rather see like not even using the bit fields, but in this case, it's the equality that stands out in my mind. But I mean, that's just a matter of perspective, really. There's no reason why either is right or wrong.
yeah. I just figured I'd call it out because a lot of the times when I see these kinds of logic bugs that lead to like bypasses of authorization checks, it is because they try to stick like multiple fields into like one bit field, instead of having like an opcode field and then the flags separately. That kind of pattern is a lot harder to get wrong in this sort of way. But yeah, I mean, it is. I think this is somewhat older code, so maybe it is from a time when penny pinching the argument buffer made a bit more sense. But yeah, like if I saw this kind of bitwise going on for an operation, like that would be kind of a code smell for me in and of itself. So uh, yeah, an interesting bug though is always coming out of Project Zero, and like I said, I think you probably could exploit this to a fair degree. It seems to give you pretty nice primitives. So
Yeah, I mean, use after free. Likely, I'm not sure about caches within XNU, but when you have that, like that is usually going to be fairly exploitable.
yeah. Continuing on some other Project Zero bugs, they also put out reports on Vuln's and Samsung Shannon Baseband 5G protocol implementation, which I believe is used in the baseband stack for like all Xenos devices, and they were fairly memeable issues. First one that we have up here was a buffer overflow when working with service area lists, which would consist of a header and an auxiliary array of elements. And the baseband would reserve 16 slots for what they call allowed and 16 slots for non-allowed elements. Um, I don't think it's super relevant, like, what those two different types are or whatever. The main problem is just that they never actually check that the number of entries provided is 16 or less for a particular type. So, for example, you can pass up to like 28 elements here, due to it's only limited by the message size at 114 bytes. Each element is a D word or 4 bytes. So, depending on which type you assign those entries, you can set 28 allowed entries, for example, and overflow that space allocated for 16. There were also 3 other reports, but they're essentially the same kind of issue, but with different lists. For example, another one was in the emergency number list where they would accept 10 emergency numbers with a max of 22 characters each, but they never actually validated that the number, like the data provided, is inbounds 22 bytes. You can specify up to 255 bytes for an entry. So just sort of classic buffer overflow issues. Which when you're getting into baseband land, that is sort of more the issues that you tend to run into. They are pretty serious though because of where they are, and the fact that they're exposed in Xenos devices. Um, and these are the ones that were disclosed. I think there were 4 reports that were put out. Um, are not the only ones that were found. I think there were like 18 vulnerabilities at Project Zero found in Shannon Baseband, and some of them they're actually holding back on because of the impact of them. They're making an exemption to their 90-day disclosure policy, because when you're talking, because a lot of these issues could end up being exploited remotely, just through like the Wi-Fi calling functionality or voice over LTE. Um, and in baseband, you don't have as like the mitigations going on the same way, so it could be fairly easy for an attacker to not only write an exploit for this, but to also deploy it. So that's kind of the reasoning they gave in their blog post as to why they don't want to disclose some of the vulnerabilities yet. The other problem is, we're talking about the Android ecosystem. So even if these vulnerabilities have been patched, especially on Samsung devices, I don't know why they do this. I hate it. They make it a real pain to be able to update your device. On Samsung, if you have done anything like custom, like if you've tried to disable OEM unlocking, or OEM locking, or anything like that, you can't do over-the-air updates anymore. You have to use like a third-party tool to update your device with like decrypted updates, and it's just a mess. So as end days, these could potentially be pretty powerful as well. And that's just an unfortunate reality of the Android ecosystem, especially on Samsung. So yeah, it'll be interesting to see if and when those issues get disclosed. But I can imagine they'll probably just be more of the same, to be honest. More of these classic buffer overflow type issues.
Yeah, kind of stupid issues. I agree. Like they're very memeable issues, as you said. Nothing in here was like a spectacular bug that I really found all that interesting. It's a lack of bounds checking effectively in all of the cases. Different bounds, like the index versus like the number of bytes, but ultimately it's a lack of bounds checking. So not a surprising issue. I did find it surprising that they were willing to extend effectively their 90-day thing. Like you don't hear that very often out of them. They do
I
call
don't
this
remember the
as
last time they did that.
I don't either. I mean, granted, they've had. So I want to say last year was the first year where they went a little bit more firm on the 90 days. Before that, they had a 90-day with a, I want to say 14-day grace period. Um, and then they got rid of the grace period because they felt like places were trying to abuse it or something, or maybe it was like 30-day grace actually. I forget exactly what it was, but I feel like it was last year where they hardened that down a bit, being like, we're going to stop doing the grace period, and now they're kind of breaking that. But yeah, I don't recall any specific cases where that has been the case, but I think a lot of the times we don't necessarily look at how long the disclosures were, so it may just have gone unnoticed too. This is one of the first times I'm seeing them kind of call it out.
Yeah. But the fact that they are calling it out in this way just kind of speaks to the seriousness of the impact these issues could have. At least the four that they classify as the most severe. So
Yeah.
yeah, baseband's kind of an interesting area. Like I said, it is typically a bit more of a soft target in terms of the vulnerabilities you find. That said, it's also a bit of a harder to research target because you typically need like specialized equipment to be able to communicate with baseband, and it's kind of its own like area with its own unique aspects. So that's probably why it's a bit of a softer target with these types of issues. Is because there's not a ton of people doing baseband research compared to other stuff, but it is, especially when you're talking about mobile devices. Uh, it is definitely worth considering, and it is in like the uh, threat sphere or scope. So
Yeah, it's definitely like a viable attack. It's not that crazy for like an attacker to be able to get themselves in position. It does take like a bit of money to buy the hardware for it, but it is something that is accessible.
yeah. All right, so that's all the topics we have for this week. So unless you have any last minute thoughts, see, we'll wrap it up.
Yeah, no shout outs this week.
All right,
I
cool.
guess except that SecGPT thing.
Yeah. Uh, just a quick thing from chat. Johnny Jimbo said, "Glad they did this on critical infrastructure." We're talking about. Yeah. So I saw some discussion around this. Actually, I'll do like a final point on it. Um, I saw some discussion of people wondering if things like this is why multiple devices, including Samsung themselves, are moving away from Xenos. Because I don't think the S23 has had a Xenos release yet. I think it's just been Qualcomm. Um, and yeah, I don't know. I do find it interesting that Xenos seems to be getting like put by the wayside a little bit, even by Samsung themselves, because Samsung owns Xenos. Like that's for their own chipsets that they manufacture. So yeah, I don't know. It could be part of it because it does seem like their firmware is generally less secure than others in the market. But um, yeah, it is still used a lot. Samsung has a huge market share, and the international phone models that are Xenos based are a big part of that. So definitely something that's worth keeping in mind and can have wide sweeping impact. All right. But yeah, that's all that we have for this week. So thank you everyone who tuned in. If you want to catch past episodes, you can find recent ones on Twitch and all of them on YouTube, Spotify, Apple Podcast, and more off of Anchor. If you want to join our Discord and follow us on Twitter, links to those are down below or in the chat as well. And with that said, we'll see you next week.